Have you ever wondered how we can visualize the journey of an object in both space and time? Enter the domain of spacetime diagrams, an elegant tool that physicists use to illustrate the dance of objects through the cosmos. A spacetime diagram is essentially a graphical representation of locations in space at various times. It's a concept rooted in the special theory of relativity. These diagrams can beautifully illustrate phenomena like time dilation and length contraction without needing to dive into complex mathematical equations. These diagrams trace the history of an object's location through time, creating a line or curve known as the object's world line. Each point in a spacetime diagram represents a unique position in space and time, referred to as an event. One of the most well-known types of spacetime diagrams are Minkowski diagrams, named after Hermann Minkowski, who developed them in 1908. These diagrams are two-dimensional graphs that illustrate events in a universe consisting of one space dimension and one time dimension. Unlike a regular distance-time graph, the distance is displayed on the horizontal axis and time on the vertical axis. The time and space units are chosen in such a way that an object moving at the speed of light is depicted as following a 45-degree angle to the diagram's axes. At its core, a spacetime diagram is simply a time versus position graph, with the directions of the axes swapped compared to a regular position-time graph. This means the vertical axis refers to time and the horizontal axis to space. When used in special relativity, the temporal axes of a spacetime diagram are often scaled with the speed of light, changing the dimension of the addressed physical quantity from time to length. To simplify the comparison of spacetime coordinates measured by observers in different reference frames, we use a standard configuration. This configuration involves two conventional three-space frames, each with observers at rest in their respective frames, but measuring the other as moving. To summarize, spacetime diagrams are powerful tools that help us visualize the journey of objects through space and time. They allow us to illustrate complex phenomena like time dilation and length contraction without delving into the intricacies of mathematical equations. They are built upon the concept of an object's world line, a unique path that traces an object's journey through the cosmos. Minkowski diagrams, a well-known class of spacetime diagrams, depict events in a universe consisting of one space dimension and one time dimension, providing an intuitive understanding of the object's journey. And finally, standard configurations of reference frames aid in the comparison of spacetime coordinates, simplifying the complex dance of objects through the cosmos. So the next time you gaze up at the stars, remember that each point of light has its own world line, its own unique journey through the fabric of spacetime, beautifully illustrated by spacetime diagrams.